خلاص اوكي بدأنا التسجيل. يلا بسم الله الرحمن الرحيم. In today's class inshallah we'll see the chapter 9 which is the timer programming in assembly and C. So here we'll see the timer. We have seen the timer. We have seen that the timer is a block that works independently from the PIC microcontroller. Yes or no? What is its main task?
Delay and counter. Timer and counter.
Very good. So I have seen that the timer, it can be used as timer to generate time delay, okay? Or it can be used as counter. So if you are using the timer as a counter, that means you are using external oscillator. And if you are using the timer as a timer, so here you are using the internal oscillator or internal clock source, okay? So the timer, it has two functions. So if we are giving the pulses to this timer from outside the PIC microcontroller, then we are using counter. So we are using external oscillator. So we are using an external clock source. If you are giving the input of the timer from the internal timer of the PIC microcontroller, so here we have internal clock source, okay? So we are using the timer just to generate a time delay. Now we have to understand how to make or how to program the timer to be a timer and how to program the timer to be a counter. So in the PIC 18 we have up to 5 timers from timer 0 till timer 5. Okay, so I will disable the animation. So we have seen that we can use them to generate time delay or as a counter. So if we are using counter, that means we are counting external events happening outside the microcontroller. That's why we call it external clock source. So the timer needs a clock pulse to tick. So this clock can be internal. In this case, we have timer or counter.
Internal, we have timer.
Internal yani timer. Okay, so and if it is external yani we are using the timer as counter. Okay, so the fourth of the frequency of the crystal oscillator. So here the crystal oscillator, we have seen that it is connected in the two pins, oscillator 1 and oscillator 2. Okay, it is fed into the timer. Okay, so this is if you are using the internal clock source. Internal clock source, yani we are using the timer to generate time delay. So the input will be coming from the external oscillator. Okay, so we take the fourth of the crystal frequency of the oscillator, and this will be the input of our time. And it is used to generate time delay, and then it is called a timer. Now, for external clock option, so the pulses are fed through one of the pin 80. What is this pin? We have seen this pin. It is RA4. So if you want to use the timer as a counter, now we are talking about timer 0. For timer 0, the input of the timer, the external input is A4. And then it is called counter. Now, let's start with timer 0. Let's see the registers that we need and how to make the program. So the timer 0 can be used as an 8-bit or as 16-bit timer. The 16-bit timer is accessed as low byte and high byte. So the low byte register will be timer 0 low. So here we are talking about the register, the main register of timer 0. The main register of timer 0 is TMR for timer 0. And it can be 8-bit. So if it is 8-bit, so have timer 0 low. The name of this register, because physically there is no register named timer 0. Physically, we have timer 0 low. And if you are using 16-bit mode, then we have timer 0 low with timer 0 high. So here we have 8-bit, and here we have 8-bit. So the total will be 16 bits. Okay, so the first register that we need for the timer 0 is just TMR 0. Okay, in 8-bit mode, we need just timer 0 low. In 16-bit mode, we need both. We need the timer 0 low and the timer 0 high. So these registers can be accessed like any other register. For example, you can use move WF timer 0 low in order to get any value, in order to give any value to timer 0 low. You can use move LW, for example, 0x0f, move WF timer 0 low. So you can use it like any other register. Okay, you can have, for example, move FF. So if you want to read, for example, we are using the timer 0 as a counter, and we are counting the number of students that get in the room. Okay, and you want to display the number of students in, for example, screen connected to port B. Then we can use move FF timer 0 low. We are reading the value of timer 0 low, and we are moving the result to port B. So generally, we can read or write to this timer 0 low. If you are using the timer as counter, so generally we have to read this timer 0 low. We are reading because we need to know the number of counts. Okay, so if you are using the timer as a timer, we have to write to timer 0 low. We have to write what? We have to write the initial value. Because if you are using the timer as a timer, then we have to generate time delay. And we have seen that the time delay depends on the initial value of timer 0. Any question about this?
Clear.
Okay, so for timer 0, we have seen that the first register is TMR 0. Now, the second register is the control register. So in order to make the control of timer 0, we need one register for the control. And the name of this register is T0 con, which is timer 0 control. So each timer, it has a control register, name it timer control. Okay, so the timer 0 control is an 8-bit register used for the control of timer 0. And here we have the bits of our timer 0. Let's start with timer, the first one, timer 0 on. So this is the bit, or this bit is like the switch of the timer. So if you want to start counting, this bit will be 1. And if you want to stop the timer, this bit should be off. So the bit number 7 is timer 0 on. So if it is 1, yani we will start the timer. If it is off, we have to stop, yani we are stopping the timer. So generally, how does it work? First of all, we have to make the configuration of the timer by giving the different bits of timer 0. And then once we have done, we can start our timer. The next bit is T0 8-bit. So this bit permits us to select between the 16-bit mode and the 8-bit mode. So T0 8-bit. So if it is 0, yani we are using 16-bit. If this bit is 1, yani we are using just 8-bit. Now the next one is T0 CS, which is timer 0 clock source. So timer 0 clock source. So this bit permits us to select between counter or timer, because here we are giving the clock source. So if it is 0, that means we have external clock. Sorry, we have internal clock. So if you have internal clock, so the frequency will be the 4th of the crystal oscillator. Now, if the timer 0 clock source is 1, that means we have external clock source. So if we have external clock source, that means we have counter or timer mode.
Counter.
External clock source.
Counter.
We have the counter mode. Very good. So this bit permits us to select between timer and counter. Now, if we are using the timer as a counter, we can make the increment on the high to low pulse, onto low to high pulse, or onto high to low pulse. So this is only if you are using the timer as counter. So if you are using the timer as a counter, you can use this bit, which is timer 0 source edge. So here we are talking about the edge. So this edge, it can be 0 or 1. That means if it is 0, the increment will be on low to high transition. So if the edge is 0, that means we are making the increment on the low to high transition. If this bit is 1, that means the increment will be on high to low transition. Okay?
Okay, doctor. If I select the internal clock,
If you are selecting the internal clock, then you are just, the oscillator will generate square signal. Okay, so at each low to high pitch, this will generate an edge, and this will increment the timer. Okay, it doesn't make sense. The increment will be on high to low or low to high. Just when we have a pulse, this will increment the counter, okay, or the timer, because now we are just generating time delay. But if you have a sensor, so this sensor, it can be incremented on high to low pulse or on low to high pulse. That's why here we have selectable edge source. Okay, now we have done with this bit. Now these 4 bits are for the prescaler. So what does mean prescaler? If the delay that we want to generate is a large delay, generally we have to use prescaler. Okay, so we have here, this bit is PSA. So the bit PSA, which is timer 0 prescaler assignment bit. If it is 0, the clock input comes from the prescaler. If it is 1, we have to bypass prescaler. So here you have to be careful. 1 means, if this bit is 1, means we will bypass the prescaler, no prescaler. If this bit is 0, there is a prescaler. So what is the prescaler? The prescaler is just frequency divider. Okay, so if we suppose that our PIC microcontroller is using 4 megahertz crystal frequency. Okay, so the instruction cycle, we have seen that it is 1 microsecond. So the instruction cycle equals the inverse 1 over the crystal frequency divided by 4, because we have seen that the input will be the fourth of the oscillator frequency. Okay, so here it will be 1 microsecond. If we are using, for example, a prescaler of 2, this instruction cycle will be divided by 2, because the frequency will not be the frequency of oscillator divided by 4, but the frequency of the oscillator divided by 4 divided by 2. So here the frequency will be divided by 2. So the period delay will be multiplied by 2. So if you are using, for example, a prescaler of 256, that means the delay will be multiplied by 256. So to generate larger delay, we need to use prescaler. So how to select the prescaler? We have to check these 3 bits. So if you have 0, 0, 0 in these 3 bits, that means we have prescaler of 2. If you have 0, 0, 1, we have prescaler of 4. 0, 1, 0, prescaler of 8, etc. Till 1, 1, 1, this will generate prescaler of 256. So we'll see when do we need prescaler and when we don't need prescaler. Yeah, let's see here. We have an example of configuration. We have this value on timer 0 control. What does it mean, this value? So what do we have as a configuration? So first of all, timer 0 on 0, the timer now is stopped. Okay, so it's not in start mode. Now timer 0 8-bit is 0. What does it mean? And we are using
16 bit.
16 bits. Okay, the next bit is 0. timer 0 clock source. The clock source is 0. 0 يعني
internal clock.
internal, يعني we are using the timer as timer. Okay, so the input will be the frequency of the oscillator divided by 4. So here we have internal clock source. That means we have timer mode. Now the next bit, it is the timer 0 source edge. So here the source edge is 0. So the increment will be on low to high transition. But this doesn't affect, since we are using the timer as a timer, it doesn't matter this value. Okay, now here we have 1. For the PSA we have 1. What does it mean 1?
Prescaler, bypass prescaler.
Bypass prescaler, يعني no prescaler. So if here we have 1, يعني no prescaler, the values of these 3 bits doesn't matter, since we are not using prescaler. So here we can have any value, 0 or 1. This will not change our configuration. Yani this configuration is for using timer 0 in 16-bit mode as timer mode without prescaler. Okay.
Okay.
Okay, so timer 0 is software selectable operation as a timer or as a counter, and also it can be used as 8-bit or 16-bit mode. We have readable and writable register. So we have selectable clock source, internal or external. We have selectable edge, and we have an interrupt on overflow. This is important. What does mean interrupt on overflow? So for 8-bit mode, if you have our timer in 8-bit mode, so you can start with any value in the timer. So if you have 8-bit mode, yani the timer or the register that you are using is timer 0 low. Okay, so the timer 0 low can start with any value. Okay, then it will start counting till the value FF. So from FF we have the value 0 0, and then we can say that the timer 0 has an overflow. So if you have an overflow, this will generate an interrupt. So what does mean generate an interrupt? That means the timer 0 IF, the timer 0 interrupt flag will be equals to 1. Okay, so you can start with any value for timer 0 low. Now in 16-bit mode, we have to use 2 registers. We have the value on both, on timer 0 low and timer 0 high. So this value can be from any value. Let's start with 0 0 0 0 till the last value F F F F. After F F F F there is an overflow, so this will generate an interrupt. Okay, so we can have 0 0 0 0, and this will generate an interrupt, means the timer 0 IF will be equals to 1. Clear?
Clear.
Okay, so let's see now, find the timers clock frequency and its period for various PIC 18 based system. So here we have with 10 megahertz, with 16 megahertz, and with 4 megahertz. So here what are we trying to find? We are trying to find the crystal, okay, the period and the frequency of the timer. Okay, so if you are using 10 megahertz crystal, what will be the period of the timer? So the period of the timer will be the crystal frequency divided by 4. So we have the 10 megahertz divided by 4, which is 2.5 megahertz. So this is called the frequency of the timer. And what is the period? The period is 1 over the frequency. So the period will be 1 divided by 2.5 megahertz. So it will be 0.4 microseconds. Okay. So if you have 16 megahertz crystal frequency, the quarter of 16 megahertz, it will be 4 megahertz. 1 divided by 4 megahertz, it will be 0.25 microseconds. If you have a crystal frequency of 4 megahertz, 4 megahertz divided by 4 is 1 megahertz, and the period will be 1 microsecond. So I've seen how to calculate this, okay? So this is called the period of the timer. And you have seen this, we calculated this previously, and we call it the instruction cycle. It is the same. Okay. So here we are calling the instruction cycle as period T. Okay. So how to calculate T? So T will be 1 divided by the crystal frequency divided by 4. You will find the number in seconds. Now let's see this flag. So the timer 0 IF, which is the timer 0 interrupt flag, is part of the timer of the INTCON register. I've seen this in the previous class. Okay. Other options of the INTCON register have been discussed before. So when the timer reaches its maximum value, which is FFFF, it rolls over 000, and the timer 0 IF is set to 1. Shabab, we have 10 minutes for this class. After 10 minutes, so please reconnect with the same link, okay? Use the same link to get into the class again, okay?
اوكي.
دكتور أفطر المغرب ولا على طول؟
Up to you. كم باقي للمغرب؟
باقي على الأذان دقيقة عندنا في مكة.
دقيقة، خلاص صلي المغرب بعدين يعني ناخذ ربع ساعة، اوكي؟
أوكي.
ربع ساعة. يلا.
جزاك.
خلينا نكمل. So we have seen that in 16-bit mode, the timer will start counting till FF, then it will roll over the 0000, and this will generate an interrupt. Okay. So timer 0 IF can be used to cause interrupts. So we can use the timer if you want to check if the timer reached its maximum value or not. We can check this flag. How can we check this flag? We have two techniques. We can use the polling technique that we have seen previously. We have to continuously checking this flag, or we can use the interrupt technique. You have two possibilities. So this is our timer 0 IF. We have seen this in the INTCON register in the previous class. So if the timer 0 IF is 0, yani the timer 0 didn't overflow. If this timer 0 IF is 1, yani timer 0 has overflowed from FFFF till 0000 if you are using in 16-bit mode, or from FF till 00 if you are using 8-bit mode. Clear?
إيه clear.
Let's see now how to use timer 0. So now let's see how to use timer 0 as timer. So the first thing to do is to load the value into timer 0 control. So we have to load, we have to make the configuration of the timer by giving the appropriate value of timer 0 control. Then we have to load the timer 0 high and the timer 0 L with the initial count value. So here we are using the timer to generate time delay. We have seen that in order to use the timer to generate time delay, we have to give the initial value of timer 0 low and timer 0 high. So here, if you are using 16-bit mode, you have to give it, first of all, the value of timer 0 high. Then you can give the value of timer 0 low. Khalas, we have done with the configuration of the timer. Now we can start the timer. How to start the timer? By making the timer 0 on equals to 1. So bit set file, timer 0 control, timer 0 on. After starting the timer, now the timer will start counting. And then at the same time, we can keep monitoring the timer 0 IF. So here we are not using interrupt, we are just pulling this flag. Okay? So when this flag becomes 1, يعني خلاص we reached the delay that we need. So we can get out the loop when the timer 0IF is high. We can stop the timer by clicking bit clear file timer 0 control timer 0 on. We have to clear the flag for the next step, and then we can give the initial value of timer 0 low and timer 0 high again. So these are the steps that we have to follow in order to generate time delay by using timer 0. Any question about this?
Clear, inshallah.
So the first 2 steps is for configuration, okay? We have to give the value. What does mean configuration of timer 0? We have to give the value of timer 0 control. And we have to give the value of timer 0 low. And with the value of timer 0 high. That's it. This is the configuration of the timer. Then you can start your timer and start pulling the flag.
And Doctor, why should we have to start with high?
This depends on the architecture. Okay.
Okay.
To load the timer 0 high first, and then you have to load the timer 0 low. The reason the value of timer 0 high is kept into temporary register, and it is written to timer 0 high when the timer 0 low is loaded. So this depends on the internal architecture. So this is for preventing for any error in counting in the timer 0 on. Okay. But for you, just load the value of timer 0 high, then load the value of timer 0 low. Okay. Let's see an example. We have to create square wave 50% duty cycle on port B5 by using timer 0. So this is our peak microcontroller. This is B5. We have just to generate square signal by using the timer. So here we know that the crystal frequency is 10 megahertz, and we have the initial count is FFF2. What does mean initial count FFF2? This F2 is the value of timer 0 low, and this FF is the value of timer 0 high. And they gave us everything. You have just to give the configuration of timer 0 or timer 0 control, and then you have to give the value of timer 0 high, timer 0 low, and then you can start your timer. After starting the timer, we have to check the timer 0 IF. When this flag becomes 1, yani we reached the delay that we need. In that case, we have just to toggle B5. Yani start the timer, make the configuration, start the timer, wait for the delay. Once the delay is reached, yani once the timer 0 IF becomes 1, we have to just toggle B5. Start the timer again, wait for the delay, and toggle, etc. So this is the program. So here in this example, they give us everything, okay? So we have just to find the value of timer 0 control. So what is the value of timer 0 control here? We have timer mode or counter mode.
Timer.
We have timer mode. 16-bit or 8-bit?
16.
16 because they give us the value of timer 0 high and timer 0 low. So 16-bit mode. Do we need prescaler here?
No.
No prescaler. They give us already the values of timer 0 low and timer 0 high. Okay, so if we return back here, so we start always timer 0 on equals to 0. We will start it after making the configuration. Then timer 0 8-bit. What do you have? 16-bit or 8-bit mode? 16-bit mode. So this bit should be 1. We need 16-bit. This bit should be 0. So we need 16.
0.
16-bit mode. So this bit will be 0. Okay, external or internal?
internal التايمر.
Internal, we are using the timer. Internal, so it is 0. Source edge, it doesn't matter. Do you have prescaler?
No.
No prescaler, so 1. Bypass prescaler. And then these values doesn't matter. So here we have the value 0x08. Okay. So this is the value of timer 0 control. And we have the value of timer 0 on and timer 0 low and timer 0 high. So خلاص we have to use move LW 0x00 move WF timer 0 control. We have to give the value of timer 0 high, which is FF, because we start with FF F2. Okay. So move LW FF move WF timer 0 high. Move LW F2 move WF timer 0 low. So we have done with the configuration. So we have to be sure that the flag is 0. So bit clear 5, the int con register, comma, timer 0 IF. Okay. We can toggle B5. Let's ignore this for the moment. Now we have to start the timer. So we'll start the timer. How to start the timer? Bit set file, the timer 0 control, timer 0 on. So the bit number 7 should be 1. Once